Welcome to Alfonso Cajero, Introduction to Cryptocurrencies, Chapter 9, How Does Blockchain Technology Work? Blockchain technology leverages a secure, decentralized, or distributed append-only ledger maintained through multi-party consensus. It's well-suited for verifying electronic value transfers without intermediaries like banks. This ledger records transactions in blocks linked via cryptography, specifically through hash functions and digital signatures. Although cryptography makes tampering with blocks nearly impossible, it's not entirely tamper-proof. Digital signatures. Digital signatures function similarly to handwritten signatures, but are used to authenticate digital transactions. They are designed to be difficult to forge yet easy to verify. Cryptocurrency digital signatures utilize a pair of related keys, a private key and a public key. The private key is kept secret and used to prove ownership, while the public key is visible and acts as the owner's identity. This system, known as Public Key Infrastructure, PKI, has been used for decades to manage identity and security in digital communications. In practice, digital signatures work as follows. If you want to send an encrypted message to a friend, you use their public key to encrypt it. While anyone can see the encrypted message, only the intended recipient can decrypt it using their private key. Similarly, a digital signature allows you to prove you possess the private key associated with a public key without revealing the key itself. This prevents the risk of exposing your private key each time you need to validate data. The digital signature is unique to each transaction, created using the private key and the specific data involved. Hash functions. Hash functions are mathematical algorithms that convert variable length input data into a fixed length string, called a hash or hash value. For instance, using the SHA-1 hash function, different inputs produce hashes of the same length. A crucial property of hash functions is that even a tiny change in input results in a completely different hash value. Hash functions are deterministic, meaning the same input will always produce the same output, making them reliable for data integrity checks. Hash functions are easy to compute in one direction, but difficult to reverse, meaning you can't easily determine the input from the hash. This characteristic is analogous to squaring a number, easy, versus finding its square root, difficult. Hash functions are fundamental to modern cryptography, used to authenticate transactions, messages, and digital signatures. Each piece of digital data, from a file to a blockchain block, has a unique hash, ensuring any modification results in a different hash. In summary, blockchain technology, digital signatures, and hash functions work together to provide a robust framework for secure and decentralized transactions. This system ensures integrity and authenticity while minimizing the need for trusted intermediaries.